What we want to do next is lay out theta horizontally. Instead of having theta go around in a circle, I want theta to go out horizontally. So this is how I've marked up my axis. I've put a mark every 30 degrees. I'm not going to worry about the 45 because it gets jammed up with between the 30 and the 60. So I've marked the 30, 60, 90, 120, 150, 180, and so on every 30 degrees. The ones in red are 30-degree reference angles. The ones in blue are 60-degree reference angles. On the vertical, I've marked a 1 and a 0.5. The other one that we're going to need, since it's 30s and 60s, is root 3 over 2, which is about 0.8660. So halfway up would be 0.75. Halfway between 0.75 and 100 is 87.5. So I'll cut that in half to a 3/4, and then that's approximately 0.8660. Those are the marks that we're going to want vertically. 0.5, root 3 over 2, and 1. And 0. And the negatives of those as well. So halfway between -0.5 and -1 is -0.75. Halfway again is approximately -0.8660. Change this to a plus. This is also why we want those decimal approximations, so we can have a more accurate graph. Let's go around and plot the points for cosine going around the circle and see the cosine from left to right instead of just going around in a circle. Cosine of 0 is equal to 1, so that'll go right here. Cosine of 30 is root 3 over 2, which is approximately 0.8660. Cosine of 60 is a half. And then cosine of 90 is 0. So we kind of have this roller coaster ride going down. It starts off, it's flat at the top, and then it gets steeper as we go towards 90. The next we're at this blue line of 120. Cosine of 120 is -1/2. Cosine of 150 is negative root 3 over 2. And cosine of 180 is -1. So it's like steep in this between 60 and 120, and then it kind of flattens out to hit the bottom when we hit to 180. So we started off at 1, and then we dropped down to 0, and then down to -1. Now we start going back up from -1. At 210, it's a 30-degree reference angle. So we'll be at root 3 over 2, negative, because we're in quadrant 3. Cosine of 240 is -1/2. Cosine of 270, we're back to 0. And now we're going to move into the fourth quadrant between 270 and 360. Cosine of 300, that's a 60-degree reference angle, so we'll be at a half. Cosine of 330 will be root 3 over 2, so we'll be at positive root 3 over 2. And cosine of 360, we're back to the beginning at 1. So we start off at the top, down to the middle, going down to the bottom, back to the middle, but going up, and then back to the top again. Then we're just going to get a repeat of what's going on because this was just tracking the x coordinate. Starting off at 1, and then down to -1, and then back up to 1. So if we go past 360, we'll be at another 30-degree reference angle. And then At 420, we'll be at a 1/2. And it's just going to repeat after this. Then we just try to connect the dots with a smooth line. A good technique for this is just try to, the three in the middle that are crossing the theta axis, kind of connect those with a line. And then kind of flatten and then kind of zip up to that line, kind of curve up to that line. And then after this linear part, it's not really linear, but after that part, kind of curve it back up to the top. And so there's the graph of y, well, it's one part of the graph of y equals cosine of theta. Is everybody okay? The shape of this graph is called a sinusoid. And if we want to make an adjective, we call it a sinusoidal. We put an O at the end of it. Sinusoidal. Any questions? Anybody still have an AM or an FM radio in their car? Is everybody familiar with the concept of AM and FM? Or is it just CarPlay and satellite radio? So AM and FM stand for amplitude modulation and frequency modulation. Is everybody familiar with AM radio? If you listen to, like, I can't remember, the Giants are on what station? No one knows because we use satellites. Which one is XM? What does the X stand for? The X doesn't stand for anything. They just use X because they think it's cool. We'll call it XM. Yeah. It would be extreme. But AM stands for amplitude modulation. So what they're doing is sending out a radio signal, and when they want to make it sound different, they modulate the amplitude. Amplitude is going up and down like this. So it's going wah, 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 wah. FM is frequency modulation, which is just squishing it back and forth. So how long it takes to do one of these cycles, that's the frequency, and they're modulating that. So they're just going wah, 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 wah. That's the sound of it too, if you listen to the radio. I'm just kidding. Okay. XM is modulating the extremeness of the signal. So I think they like all the equipment is just like fueled by Mountain Dew or something like that. Good question. Comment? I think you all might be young enough to have avoided all the X stuff that was running around in like the 90s. Is anybody a fan of the X-Men in comics? Because extreme stuff and X was so popular, it was just X everything. They had like the X this and X that, X Force. And they had one Executioner's Tale, but they left off so it was just Executioner's Tale. No, this doesn't make any sense. I think it was tail. Anyway, they spelled executioner, executioner, so just executioner. That's not a word. That's really a word. This needs to stop. And it did. So look at this. Any questions? Not about X-Men in the 90s. Sinusoidal graph. We could do the same thing with sine. It would start off at 0, go up, down, and then up again. And then repeat 0 to 360. This is how we're going to practice taking a function that is designed to go around in a circle and stretch it out into a function that goes horizontal like our functions normally do. So we can measure things that go up and down over time. So like high tide, low tide, high tide, low tide. And instead of going from 0 to 360, maybe from high tide to the next high tide, it's 24 hours. And we can figure out a function that will describe what's going on. And that's going to be enough for today. I will see you all on Tuesday. And I'm going to make some more due dates for homework. So I'll see you all on Tuesday. Everybody have a good day. And thanks for playing.